Hi there and welcome everybody. I'm Bob Osterlin, one of the organizers of the Spectrum Scale user group, and I'd like to invite everybody to join our talk today on Spectrum Scale Strategy. Speakers will be Ted Hoover and Wayne Sawdon. Before we get started, I'd like to make a sort of a brief announcement regarding SC20, which is traditionally held in November. The announcement went out today that conference will be a fully virtual conference. So no in-person meeting there, obviously, this year, but we're currently organizing some activities and some meetings around SC20 as part of that, both with IBM and part of the user group. So stay tuned for information about that, and we'll be hoping you can join us there as well. So I'll get started and introduce our two speakers. Ted Hoover is the program director of Spectrum Scale product development, and he's responsible for the worldwide development of Spectrum Scale Cloud, Container, and the performance engineering teams. And Wayne Sawdon, he's been with IBM since 1982. He was on educational leave at Carnegie Mellon during the 90s and returned to IBM and joined the Tiger Shark research project, which, if everyone's not aware, the Tiger Shark was the original research project that GPFS and Spectrum Scale came out of. And Wayne has mostly worked on file systems throughout his career, along with data management. And he is currently the CTO for Spectrum Scale and ESS at IBM. So Ted and Wayne, I'll turn it over to you.
Thank you, Bob. So today, Ted and I are going to talk about the strategy for Spectrum Scale. GPFS has a long history. If you've heard this talk before, you'll know it goes back quite a ways into the 90s. It started as high-performance storage for supercomputers, primarily in the national labs, but through the years, it has extended itself into the commercial marketplace. It's pretty much anyone that has data-intensive workflows and needs analytics on unstructured data loves to have Spectrum Scale. So some history, it started as Tiger Shark, which Bob mentioned, in '93. This was a video download service that we offered 8 years before Netflix offered download videos. So it's quite a good technology. In '98, it came out as a general parallel file system, primarily for IBM supercomputers. It has, as you've seen, runs on the world's largest supercomputers. And by 2014, it got rebranded into Spectrum Scale. The rebranding isn't so much about performance. It's still high performance analytics on quantities of unstructured data. It's more about marketing and about product features that we focus on. So even today, we're still refocusing the product as going forward. And as you'll see from Ted, our focus now is on clouds and containers. So this will be kind of interesting. So if you think of Spectrum Scale as GPFS for high performance HPC workloads, you're kind of missing out the point of it. It has evolved tremendously over the last 25 years. Supports for workflows have been in place for quite a while. We have multiple protocols, object, POSIX, NFS, and it kind of doesn't matter which one you use. You can still access all of the data all of the time. So you can ingest data via an object protocol, run analytics via HDFS, Hadoop, Spark, and view the results in POSIX. And it's all the same data. We don't have to copy it. We've had support for object for quite a while. This is very low latency, high performance object. If you haven't tried it, you should. We support OpenStack virtual machines. This is how we develop it internally, is with these virtual machines help us. One of the key features is a common namespace between Spectrum Scale clusters. Today, we run these on clusters in different parts of the world, different labs, but very soon you'll see we can get the same common namespace, whether you're in the cloud or between clouds or multi-clouds. We still preserve a common namespace so that you can see all of the data, regardless of where it's located, on-prem, in the cloud, in someone else's cloud. So that's a feature that we are kind of proud of. The namespace also includes the data management features. So we can automatically destage cold data. We used to destage to tapes. but you can also destage it to objects as well. Scale has invested in GUIs and REST and ease of use features. We have investments in HADR, real-time audit security. There's a prior talk on stretch clusters, which is an active HA solution. So there's lots going on in Scale. It isn't just for HPC anymore. The infographic shows you the history and the timeline. Over on the left, it shows us as a video server in its initial beginnings. If you look at the verticals, you'll see various points in time where we ran on, say, ASCII White. This is the world's largest supercomputer at the time. This is 2001. You know, ASCII Purple's in there as well. If you go to the far right, you'll see us on Summit and Sierra, which until recently were the two largest supercomputers in the world. All the points in between, you can see all the enhancements we've made for ease of use, for making this into a commercial file system while still preserving high performance on unstructured data. The net of it is today, if you look at the 100 largest companies in the world, Scale is run on 57 of them. 9 out of 10 of the top auto manufacturers run Scale. 9 out of 10 of the top banks run Scale. Basically, anyone who wants to do high performance analytics on vast quantities of unstructured data loves to run Scale. So that's where we are today. And with that, I'm going to turn it over to Ted, who's going to actually start the strategy talk. So Ted.
Thank you, Wayne. So, you know, as Wayne said, Scale has a long history of innovation, long history of developing technologies that is intended to evolve, you know, with the workloads that our clients have. And, you know, building on this history of innovation, we want to talk a little bit about where we're going next, right? What are the type of things that we're investing in Spectrum Scale in order to kind of evolve with the industry? You know, a lot of this insight is driven by conversations we've been having with you, our clients. We've been also seeing where there's growth in the storage industry as workloads are evolving, new workloads are emerging, new technologies are being adopted and used within the industry. And we'll spend some time talking about each of these here, you know, talk about what we're doing in the cloud, work that we're doing around DevOps, you know, big area, new area for us around AI and data management, and also continued investments in security. And as always, the foundation of what I think Scale brings to the market is performance. Next slide, Wayne. So let's first talk about clouds. One of the questions I get asked all the time is why is Spectrum Scale moving into the cloud? The reason is because you are, right? The workloads are moving into the cloud. The question is really, you know, how is Spectrum Scale moving into the cloud? And as we've been talking with a variety of different clients, we're finding there's a variety of different models, right? Primarily, you know, they're using both public, private, on-prem, connecting with a variety of different multi-cloud environments. And so this is really, as you'll see, shaping a lot of our investments and how, you know, where we're trying to take Spectrum Scale in the future is in order to support these types of multi-cloud hybrid environments as we go forward. Next slide, Wayne. And as we also been seeing, we're still seeing a continuous growth of data. Combined with hybrid multi-cloud usage, you know, many of our clients are storing data in different on-prem file systems, different cloud file systems, and they want to be able to connect these together. We're seeing workloads that are being run across a variety of different spaces. Move forward one more again, Wayne. And so a big part of our strategy, as you may expect, is also shaped around an acquisition that we did last year that I'm sure you had heard of in Red Hat. And the technology and infrastructure that Red Hat brings to the IBM portfolio and our Spectrum Scale portfolio has enabled us to drive to be the world's #1 hybrid multi-cloud provider. So next slide. So the second thing that we're also seeing movement in the industry is a shift to containers. We're seeing a lot of different industries, all are different types of in workloads that we support, whether it's AI or HPC or analytics or database type applications, there's a big shift moving into containers. And the ecosystem that's around that is equally important in terms of how, we need to take Spectrum Scale into this environment. So, we're looking at what does it mean for Scale to operate inside container environments? How do we need to integrate with other application workloads? And we're building that strategy around technology that's provided by Red Hat called OpenShift. Within OpenShift, there's a Kubernetes component. There's tools that deliver that self-service, automated, enterprise-grade type features for containerized application workloads. Next slide. So what does this mean for storage, right? Historically, our traditional storage, we've been providing that underlying infrastructure to support HPC and analytics workloads, administered from a centralized location. We're moving now into the middle phase where, we need to be container-ready storage. As workloads move into become containerized, we need to be able to connect those workloads directly with existing Spectrum Scale environments. And so you'll see that we've been making a variety of different investments enabling containerized workloads to work on top of Spectrum Scale, enabling some of the extended features around snapshots, clones, and replications, but still Spectrum Scale is operating as a standalone pre-installed entity. And we're moving in a direction where storage is being asked to be container native, right? Where storage or Scale is deployed inside a container with enterprise data management features, directly supporting containerized workloads, but also working within that ecosystem that many of our cloud infrastructures are currently supporting. So we're making investments within the Spectrum Scale product offering over the next couple of years to help move us in this direction. Next slide. So, at a high level, when we think of cloud native storage, or we think about what we're doing to deliver, Spectrum Scale in the cloud, we think about our purpose, our mission is to deliver high performance file services for these containerized application workloads. I often tell many of our clients as we're talking to them, we are looking at a variety of different requirements in this space. And one of the things that we need to do, the reason that people use Spectrum Scale, that value proposition we are taking with us into the cloud. There's a lot of different things that we could do in the cloud, things that we may be able to do quickly, but don't really integrate into the ecosystem and may not necessarily preserve our value proposition. So we've been very careful in talking with a lot of clients. So this slide really shows what our main focus is. We're trying to continue to support those workloads for high performance file services, analytics, cognitive, high performance computing, AI. Those workloads that run on-prem today that are running in the cloud, we're trying to connect Spectrum Scale in order to continue to provide that same level of performance and scalability that they're used to on-prem. We also recognize that we need to support that ecosystem. Containerized applications, containerized storage, ephemeral and persistent types of volumes that are necessary to work within that cloud ecosystem. Also, flexible deployment. Users in the cloud want to dynamically provision and configure and upgrade their systems. They're not statically managed as many of them are on-prem. We also need to support multiple clouds. As noted earlier, many of our clients are using more than one cloud. And so we need to come up with the common infrastructure that allows us to support a variety of different clouds and support a variety of different hybrid use cases. We've seen clients that are bursting workloads into the cloud. They want to be able to move their data into the cloud so that they can run those workloads. We want to leverage things like our AFM to create that single namespace to enable these types of workloads. We have users that want to connect data sets on different clouds in order to run life science type workloads. AI type workloads, connecting weather data into different types of workloads. So we need to be able to support multi-cloud data sharing. And a use case also has been archiving, backup archiving data into the cloud. And then also using on-prem infrastructures to accelerate compute environments that are storing their data in the cloud. And finally, we want to be able to work with our partners. Many of our partners that are using Scale, some are already using Scale inside the cloud, and we want to continue to provide services and the tools and the integration into the ecosystem that's necessary for them to be successful too. So on the left side, I like to show that we started with Spectrum Scale as a bare metal deployment, running within an on-prem environment. Over the last year, we supported our first instance of supporting Scale for containers was the rollout of storage enabler for containers version 2 that allowed containerized applications to talk to an existing Spectrum Scale bare metal deployed infrastructure. That infrastructure, that model evolved over the last year, and we are now supporting an industry standard CSI, container storage interface, that allows us to not only integrate with Kubernetes, vanilla Kubernetes, but also integrate into a broader OpenShift interoperability. Again, still connecting Scale for containers. Where we like to move to the right-hand side is, and we're currently working as a research project to put Scale in a container. You'll hopefully see more about this over the next few months, where we'd like to integrate Scale into a container or pieces of Scale into a container initially, and do tighter integration with an OpenShift, common resources, support core OS, support next versions of OpenShift and Kubernetes, and deploy that out in as part of our product offering. And ultimately, we'll be at some point fully containerized and integrate within a variety of different cloud packs that are offered within cloud environments, whether it's application cloud packs, data integration, multi-cloud management, and security cloud packs. We're working hard to leverage everything that we're doing and building that out. Next slide, please. So we're also, our offerings within Spectrum Scale in the cloud are also evolving. As you may know today, a few years ago, we actually rolled out what we call in IBM a lift and shift model of Spectrum Scale on IBM Cloud. We wrote a red paper around how you can deploy Scale in IBM Cloud, not necessarily taking advantage of the ecosystem, but managing it in the same way that you're managing a bare metal type environment. We also rolled out a version of Spectrum Scale on AWS, Amazon Web Services, built around their common services, Cloud Foundation scripts, and deployed as an AMI. And Scale over the last few years has also been deployed inside partner solutions, some of which is visible to the end user, some of which that are not. We ultimately want to get to where, when Scale is containerized, we can continue to integrate partner solutions and integrate into cloud packs to support very rapidly a multi-cloud environment, still maintaining all the features of Spectrum Scale that people value. Next slide. We're also looking at what this means from a hybrid. I mentioned before that we currently support today using Scale, the feature AFM features with Spectrum Scale to create a common namespace across on-prem, cloud type environments. And as we move forward, we're continuing, as we get into multi-cloud environments, we think that AFM is an integral part of that strategy in enabling data to be moved between on-prem and cloud environments in the other direction. And so we're making big investments in AFM to help improve the integration, interoperability with these environments as we go forward. Next slide. So we also, as we started into this journey into the cloud, as we talked to a variety of different clients and as we rolled out some of our early solutions on AWS and others, we realized we're going to be challenged in terms of a traditional deployment model. That traditional deployment model is not really going to be good enough to enable us to work effectively in cloud environments. And ultimately, we'd like to be able to take advantage of that on on-prem environments. And so we've also been making a lot of investment within Spectrum Scale development to improve how Scale is deployed and provisioned. So we've taken on a mission where we're put resource on we would call our DevOps, cloud DevOps team to create an environment where Scale can be deployed quickly. It can be deployed through microservices. It can be integrated with a variety of different workloads very quickly, and it can work on-prem across multiple clouds and be also supported within our integrated hardware solutions. So next slide, please. So a core part of that strategy is built around the use of Ansible, and more specifically Ansible playbooks and the different types of roles that we can support. So we started this project last year. We've been in the process of developing a variety of different playbooks that would allow us to very quickly deploy Scale both on cloud with containers, some pieces that you've seen on ESS, and on-prem environments. And we actually, in a few months ago, released the initial version of these playbooks in an open source community online. If you want to leverage any of these pieces today or even make contributions back to this project. So we're continuing to improve upon that version of the playbooks. We like to ultimately roll this out as the model and where we are going to install all the various components of Spectrum Scale from AFM and GUI and ECE. We'll still work on that over the next year or so, but you'll see more and more pieces of this coming together. The first instance of this will be coming out in our near-term updates on some of our cloud offerings, but you'll see this rolling out in some of the product offerings a little later. Next slide, please. And built around this for especially for cloud is also leveraging some of the tools for provisioning and installing leveraging these playbooks. So on the cloud environments, we've been focusing on using Terraform that allows us to install or provision cloud resources on a variety of different cloud platforms. Building what we're doing with containers around this, and also integrating what we're doing with bare metal deployments, whether it's our hardware solutions or our on-prem type environments, building around this new common infrastructure that's unified, giving us that flexibility that we need, and hopefully gives you the flexibility to deploy Scale in the most effective way in your environment. So I think the next slide, I'll turn it over back to Wayne, and he can go through some of the things that we've been doing around AI and analytics, performance, and security.
Okay, thanks, Ted. Were there questions? Did you want to take questions here? Or do you want me to
Yes. If there's any questions, please post them on the chat. We can answer them here, or we also have some of our panelists that are able to answer questions while we're presenting. And if we can't answer them today, we have been posting the answers to those questions when we post the recording.
Okay. So I want to take us into the AI section. AI and workflow and data management for AI. These are especially hard problems due to the volume of the data, the sources of the data, the fact that the data is typically siloed. So you have to be very flexible in how you collect data, how you process data, where you put the answers. It's lots of problems in here, but we're investing to come up with a complete ecosystem solution. Let's see. So this is sort of a representative of the standard AI pipeline. Data from the edge or from sequencers or whatever instrumentation comes in, is ingested into the file system. There is some work to clean the data, to transform it, and then to classify it and tag it and basically get it ready for the analytics. Substantial time is then spent training models or doing genomic analysis on the data. Eventually you end up with some form of insight on what came in. So this is kind of the basic model. It's kind of a generic version of an AI workflow. So if you look in greater detail, what we're actually doing is we're building pieces for each stage, and we're assembling a complete ecosystem to do the AI pipeline. So the data can come in, it could come in globally into the IBM public cloud or an IBM cloud. It could come in off a sequencer to a local on-prem storage, say Spectrum Scale. But it's how you ingest the data for the processing. Once we have the data, we have tools now from Spectrum Discover to classify the data and to tag it. And fundamentally, it's doing an important job where later when we go to do the analytics, we know what data to draw. And so you're going to see this a little bit later on. The analytics itself may be Spark Analytics on HDFS. Spectrum Scale can do this. It could be MLDL, which is another strong point for us. The results that come out is typically fed back in. If you're building a machine model, the result of the analytics is fed back in as new data so that the model can be refined. We're also putting together the components for archiving the data and preserving the data. So it isn't just Spectrum Scale. It's sort of this whole collection of products to manage these entire pipelines. So one of the problems that we're seeing for AI is how to determine what data we actually want to run our analytics on. Exabytes of data, it's common for customers to have petabytes, even to exabytes of data for their AI analytics. Unfortunately, the vast majority of this data is cold, and it's not of interest, except periodically. You may want to run some trend analysis. But when you want to build a machine model, there's very specific data that's hot, and you want to be able to identify this data and run your analytics quickly on it in order to keep your very expensive resources, your GPUs, CPUs, keep them busy. So the solution that we came up with is to think about your storage as two tiers, that there's a capacity tier, which is storing these petabytes, exabytes of data. But then there's a high performance tier where you actually run the analytics. And these tiers have different properties. One is optimized to cost, one is optimized to performance. So they're very different structures. The high performance tier, as we see it, is Spectrum Scale. It's a scale out clustered file system. And just like any other Spectrum Scale, but the difference is that it doesn't own the data. It's fundamentally a cache from the data lake. So when Spectrum Discover tells us to run the analytics, it basically curates the data and gives a list of data it wants to have analyzed. It gives us the scale. We can prefetch the data, or we can fetch it on demand and run the analytics on it. We don't transform the data. It is a pure cache. You can have multiple high-performance tiers on the same data lake. It can update itself as new data arrives. It can be updated. It can revalidate. If someone changes things, it will revalidate and refetch the data. IBM has a product called the Spectrum Conductor, which is in fact a workflow manager, which allows us to schedule these jobs and run the batch jobs on the analytics. The data lake, the Spectrum Scale doesn't care what the data lake is. It kind of doesn't matter. And whether it's IBM COS, Cloud Object Store, or a public cloud, Amazon or IBM, or basically any high capacity data store, we will fetch the data from it, cache it, run the analytics, and put the results back. What's interesting about this solution is that it doesn't matter whether the high performance tiers on-prem and the capacity tiers on-prem or in the cloud. For that matter, you can reverse it. You can run the high performance tier in the cloud and have your data in the cloud or on-prem. It kind of doesn't matter how we do it. So this packaging is something that we call a data accelerator for AI and analytics. And the goal of it's very simple. I mean, we want to accelerate the real-time analytics and the inference. The time to deriving value from your data is what we care about. So we are building the complete solution for your workflow for AI. Another area we're interested in is security. IBM firmly believes that your data is the crown jewels of your company. And as such, it's our job to protect your data. So if you look at data security, what this chart shows you is there's lots of ways to think about it. There's standard, industrial compliance, HIPAA compliance, NIST, FIPS. We do those. There's also features within the file system for keeping your data secure, encryption, secure deletion, shredding, file audit logging, immutability. We do these. There are advanced features that are coming or in the product today, things like multi-factor authentication, where you have to have a secondary method to prove who you are. File set level auditing and audit logs that we can track access to the data. Antivirus is another one we're investing in. Going forward, we're looking at these complete ecosystem solutions for security. Cyber resiliency is a very hot topic today on how to detect intruders, how to stop an intruder in his tracks. So there's lots of work on us integrating with other SIEM, that's a typo, such as QRadar or Splunk. So lots of investment here. This is a little detail of something that we just did on integration with QRadar. QRadar is IBM's security information and event monitoring system, which is looking for anomalous behavior amongst users. So it can tell when you have an intruder. It does this by monitoring access to all the files and including denied access. If a user comes in and he's wandering where he shouldn't be, it can detect it. And we're putting in the features in order to stop them immediately in real time. There's a blueprint on this. There are various papers. There are links to these here. Go read up on it. This is an exciting area, and we're investing heavily in security. Performance. Spectrum Scale has been known for performance from the very beginning. We are continuing to evolve it as the hardware evolves. We're continuing to work with it as well. Last year, we introduced the feature called the Erasure Code Edition, which basically allowed for single-tailed storage or storage-rich servers. If you put your disk drive into a node, we can connect them all and run erasure coding over them and offer you dependable, reliable storage. As storage evolves to become persistent memory, 3D cross-point octanes, we can leverage this now. So by running ECE across nodes with persistent memory, we can build extreme high performance storage, just part of Scale. So we have a research project that's looking into the details on how to exploit persistent memory. One of the areas is in cooperative caches. These are consistent caches, but it's cooperative across all the nodes in the cluster. Other things like topology-aware replication we're investigating. And this is where you can think of it as a cross between FPO, a shared nothing cluster, and ECE. It's a way to put data on a specific node so you can run analytics on that node and minimize the network activity or possibly eliminate it. This type of techniques also apply to read ahead and write behind job scheduling. You can read ahead and preload this storage, fast storage for your analytics. You can also write behind. So this is kind of a notion of a burst buffer. This leads to the concept of eventual durability, that new data that can be written very quickly into this persistent memory, and later we will destage it and make it durable and highly available to all the nodes. So this is a major investment. This is something Scale has to do to stay current with the hardware. Other things that's going on is the hardware is evolving. Everybody sees this. Everyone knows this is true. PCI Gen 3 is here. Here this year. Gen 5's coming. We know it. We've seen it. This is true for networks. It's true for storage. It's true across the board. NVMe over F is an interesting technology. NVMe over fabrics. Because it allows us to compose storage differently. And so rather than having fixed blocks of storage with exactly 2 servers for the storage, we can make more dynamic composable configurations. So this allows us to have high capacity offerings compared to high performance offerings onto the same basic storage. So different building blocks compose different storage. Smart NICs are coming. These are very interesting. TCP, IP offload, encryption, compression, all of these are done on hardware in the client nodes. This is an exciting technology that we're investing in. This is the future. Let's take advantage of it. So what's interesting to note is if you look at the technology coming, we fully expect hardware performance to increase by a factor of 10 in the next few years. So very quickly, the hardware is going to be really fast. And this puts the onus on the file system to enable that performance. So this is a major investment for us. We intend to continue our performance leadership, and this is something we're not walking away from. And that's all I have. So thank you. Any questions?
Yeah, there were a few questions that we answered in the chat. Will there be a replay available? Yes. Once the recording comes back and we annotate it with the Q&A.
Yeah, there's a YouTube channel where we've been posting the talks, previous talks as well. So if you missed any of the previous ones, those will also be available. Give us they should appear there as well. All right. So before we wrap up, I wanted to remind folks that there will be another talk tentatively scheduled for September 9th. It'll be an update on performance enhancements in Spectrum Scale by John Lewars. So you can put that on your calendar, and you'll see more information about that soon. But I wanted to thank Wayne and Ted for the talk today. Some great information on strategy going forward. And thanks for joining us. And we look forward to seeing you on the next call.
Thanks, Bob. Thanks for hosting us.
Yeah, thank you.